Welcome. Today we will explore the fascinating processes that powers our sun, the relationship between the light and energy, and the structure of the sun. And by the end of this lesson, you will be able to create models that explain nuclear fusion, the sun's structure, and electromagnetic spectrum. Let's begin. The sun produces an immense amount of energy through a process known as nuclear fusion. This process occurs in the sun's core where temperatures reach about 15 million degrees Celsius. Under these extreme conditions, hydrogen atoms move at an incredible speed, colliding with enough force to overcome their natural repulsion. When these atoms fuse, they form helium, releasing a vast amount of energy in form of light and heat. This energy is what powers the sun, and eventually it reaches the earth, supporting life. This energy travels outward through the layers of the sun, eventually reaching the earth and supporting life. Now let's try to create a simple model to visualize this process. In this model, the blue items represent original hydrogen atoms headed for first collision. During the first collision, the two protons combine and one of them converts into a proton that forms a new isotope of hydrogen represented by 2H. This new isotope of hydrogen proceeds to the second collision but with an original hydrogen atom. It is during this second collision that energy is produced and radiated in form of gamma rays. This model also indicates that nuclear fusion is a progressive reaction that keeps going on and on and on and on. Light, as we see it, is only a small section of the vast electromagnetic spectrum. Different types of light have different wavelengths, which determine their energy levels. Shorter wavelengths like blue and violet light have higher energy, while the longer wavelengths such as red light carry less energy. This principle applies to the entire electromagnetic spectrum, from the low energy radio waves used for communication to high energy gamma rays capable of penetrating even dense materials. The sun's structure consists of multiple layers, each playing a crucial role in energy production and transfer. At the core, nuclear fusion generates energy. Surrounding this is radiation zone, where energy slowly moves outwards by radiation. Next, the convection zone, which circulates hot gases transferring heat to the surface. The photosphere emits visible light, making it the layer that we can see. The chromosphere produces ultraviolet radiation, while the corona extends outwards, releasing charged particles in form of solar winds. Understanding these layers helps us to see how energy is distributed from the sun into space. Electromagnetic waves are classified based on their energy levels, ranging from the least to the most energetic. The lowest energy waves are radio waves. They are used in broadcasting and communication. Moving up the spectrum, we have microwaves, followed by infrared radiation, which we experience as heat. Visible light, the only part of the spectrum detectable by our eyes, sits right in the middle. Beyond the visible light, ultraviolet radiation carries more energy and can cause sunburn. X-rays have even higher energy, penetrating the body for medical imaging. At the top of the spectrum, gamma rays have the most energy and can be dangerous in high doses. Recognizing this pattern helps us to understand the many ways in which light interacts with the world around us. Higher energy level waves like gamma rays and X-rays are dangerous due to their ability to penetrate materials and alter cells. Meanwhile, lower energy waves like radio waves, are used for communication. To summarize, the sun's energy is produced by nuclear fusion, which occurs at its core. Light waves vary in energy depending on their wavelengths, with shorter wavelengths carrying more energy. The sun is structured in layers, each layer with a specific role in energy transfer. Electromagnetic spectrum categorizes different types of waves based on their energy levels. By understanding these concepts, we can see the sun's crucial role in sustaining life on Earth. Keep exploring and discovering how these principles shape the universe.